This is lesson 55 from Saxon Algebra 1. We're going to start by talking about complex fractions. And to start, we're going to review the denominator-numerator same quantity rule, which we just discussed recently. And we're going to start with an example of the number 5. I can take the number 5 and I can multiply it by 2 over 2 without changing the value of 5. Because as long as I'm using the same thing to multiply as I do in the numerator and the denominator, it will not change the value of it. So 5 times 2 in the numerator and keep 2 there in the denominator. So 5 also equals 10 over 2, or 10 halves. 10 halves is just another way to write the number 5. We've changed the numeral, but the number it represents is unchanged because 2 over 2 has a value of 1. And that's why you can multiply the denominator and the numerator of a fraction by any non-zero number without changing its value. Fractions of fractions are called complex fractions. So here is an example of a complex fraction written in all variables. If we have a over b, that's just a regular fraction, but it becomes a complex fraction when we have another fraction under it. So it's sort of fractions within a fraction. And the thing to keep in mind that our book reminds us is in this scenario, we cannot have any of our denominators equal to 0. So in this situation, b cannot equal 0, c cannot equal 0 because it's in that denominator, and d cannot equal 0. So they're just kind of reminding us of that as we work with it. Now, if we want to take this complex fraction and simplify it, because this is a lot to work with and deal with when we have those kind of fractions within fractions. To simplify it, we are going to take the reciprocal, and I'm going to write that word out because that's kind of a new word possibly. So the reciprocal, what that really means is if you have, let's look, for instance, just at the denominator of this complex fraction. If we have c over d, which is that denominator fraction, the reciprocal of that fraction is just to flip it and put the original denominator in the numerator and the original numerator in the denominator. So the reciprocal of c over d is just d over c. It's just sort of flipping it. So you can multiply this complex fraction by the reciprocal of the denominator, but we need to do that twice. We're going to do that to the denominator and then make it a complex fraction and have that same reciprocal in the numerator. So we're still using that rule. We're allowed to do this because this just equals 1. So we're just multiplying our original complex fraction by the number 1, which is why we're allowed to do this. But by choosing the reciprocal of the denominator, that is going to allow these d's to cross out and these c's to cross out. Now, all of a sudden, this is no longer a big complex fraction because now we can multiply what we have left up top. So we're going to do the numerators up here, which is a times d. And now the denominators are b times c. So that just made this a lot more simplified. Because again, we started with a over b over c over d. So we had like two fractions within a bigger fraction. And now we just have a single fraction that has two variables in the denominator and 2 in the numerator. So that's the practice you're going to do at the beginning of lesson 55. We're going to do one more example before we move on to the next concept. They want you to simplify this fraction, a over b over c. And a lot of times when they write this fraction, the first fraction bar that they write might be smaller or less wide. So the wider bar is kind of showing you that you have up here a fraction and then just a single down. Oh, excuse me. You have a single value in the denominator. So in this case, we are going to take the reciprocal of the denominator. Now, our denominator here is just a c. And a c is the same as just a c over 1. So to find the reciprocal, I'm going to say reciprocal, we're going to flip it. So if it was just a c, we're going to now have it 1 over c. So we are going to multiply the top and bottom of this bigger fraction times 1 over c. So I'm going to make my big fraction. I have 1 over c down here, 1 over c up here. And again, we're multiplying, so I'm going to use that, or I could use parentheses too. You can use whatever you're comfortable with that makes it clearer to you what you're doing. So again, this is still representing like c over 1. So our c's cross out, and of course the 1's cross out anyway. So we just have in our numerator a times 1, so it'll just be a. And in our denominator, when we multiply those, we get b times c. So this is our new fraction that we created, and it makes it a lot easier to work with things later. So there's a couple other example problems, but they still have this same pattern. I'm just going to show you one more example because it's a little more complex, where they start you with a over x, and then your bottom fraction of this complex fraction has a binomial in it. That a plus x makes it a little more complex. But you're going to use the same strategy where we're going to multiply it top and bottom by the reciprocal of the denominator. So if we're going to flip that fraction, we're just going to put the a plus x on top and b on the bottom. And then we're going to rewrite that whole thing again up here so that this whole a plus x cancels out and this whole b cancels out. And then up here we have a times a plus x over x times b. And then they often let you just end like this. This is how they leave the answer, or you could distribute that a if you like. Then the next piece of the lesson talks about the division rule for complex fractions. So the rule for dividing fractions is sometimes stated as dividing one fraction by another fraction. You need to invert the fraction in the denominator and multiply. So in the past, for example, if you had 2 times 3 and you were told that that's divided by 4/5, you would invert or take the reciprocal of the denominator and multiply it by the numerator. So I'm flipping that 4/5 and making it 5/4. So you could turn that division problem into a multiplication problem. So we're going to do the same thing with variables. So if I have m over n and x over y, I am going to take the reciprocal of the denominator. So what we just did in the previous lesson is the same thing, but instead we're just going to rewrite it straight off as m over n and multiply it by this reciprocal, y over x. So it equals my over nx. So it's just skipping that theoretical step of using the division rule. So we should do one more example problem just to make sure we're understanding these concepts. So if we have 1 over r divided by 1 over z, we could do what we were doing before. So one way to solve it is to multiply the top and bottom by the reciprocal of the denominator and actually physically cross these out and then multiply the numerator. Z times 1 is Z, R times 1 is R. So ZR. So that was that first thing we were doing at the beginning of the lesson. Or we can remember this rule of dividing, that if we start with that 1 over R and have 1 over Z, instead we can just rewrite it, instead of as a division problem, rewrite it as a multiplication problem where we're already starting out by flipping or taking the reciprocal of that to get the same answer. So both processes we showed in this lesson, the one we first started out with by using the reciprocal top and bottom, and the second method of just looking at this division problem as a multiplication problem where you're just using the reciprocal, they get you the same answer. They're just two different ways to look at going about it.